In this video, we are going to work on the characteristics of quadratic functions. Quadratic functions are the ones where the highest exponent is a 2. In other words, these functions are degree 2. Quadratic functions, if you graph them, are always going to form a parabola. So, let's start with problem number 1. Well, they were nice enough to give us this picture. So, when we talk about the domain of any function, we're talking about the x values. How far to the left does it go? How far to the right does it go? Well, this goes to the left forever, alright, and it goes to the right forever. So that's why the domain is going to be from negative infinity to positive infinity. On the other hand, the range talks about the y values of the graph. So the range, and we're going to do it always from bottom to top. The lowest value is here at -1, and then the highest value, it goes up forever. So that's why the range is going to be from -1 to infinity. Now notice I use the square bracket on the -1 to show that the graph includes -1. It touches. Now, the extrema. When we talk about extrema, we're talking about is there a maximum or a minimum. And for a parabola, it's always going to be just the vertex. So this is a minimum, and we see that it is -1, comma, -1. Okay, and that is a minimum. So I'm just going to put min next to this. Now the axis of symmetry. The axis of symmetry is the line that goes right down the middle of any shape, but in this case a parabola. A vertical line is going to be always x equals a number. So this axis of symmetry is x equals -1 because it's a vertical line at -1. A horizontal line would be y equals the number. So when they say increasing, decreasing, we are still looking for intervals. Where is the graph increasing and where is it decreasing? Let's see, let me erase some of this. So if you were traveling on this parabola from left to right, part of your journey you would be going downhill and part of your journey you would be going uphill. Alright, so I'm going to start over here. So from left to right, I'm going downhill, downhill, downhill. Okay, until I get right here. And then I change directions and I start going uphill. Okay, from left to right, the downhill part of the graph is decreasing and the uphill part is increasing. So when we do an interval, we are always dealing with x values when we're doing increasing and decreasing intervals. X values. So the increasing part is here in green. But let's talk about the x values of the green. Okay. The green starts here at -1. And does it end here at almost +1? Now remember that this really goes forever in this direction. So that's going to be from -1 to positive infinity because it's going to the right. So increasing is from -1 to positive infinity. Alright, we are putting a round parenthesis at the -1 because to the left of -1 it's decreasing. To the right of -1 it's increasing. But right at -1 it's neither increasing nor decreasing. So we can't include the -1. Now the the decreasing part of the graph is the pink. Now we can see x value wise it ends at -1. So it's going to be something comma -1. Now coming from the left, this goes to the left forever, so that's going to be -infinity. Okay, so -infinity to -1, because this is negative infinity over here. To the left and to the right, we have positive infinity. Okay, now let's talk about end behavior. So as x approaches infinity, okay, x approaches infinity. That means as the x values go to the right, as you go to the right. And then the question is, what happens to the y values? Well, as we go to the right, can you see that the y values go up forever? So as x approaches infinity, the y values approach infinity. Okay, because as we go to the right, it goes up. Now, what about as x approaches negative infinity? Alright, that means as we go to the left. So as we go to the left, you see the graph is going up again. So again, that's going to be positive infinity. Now, average rate of change from 0 to 2. That's what this means. Average rate of change. Well, average rate of change is just the slope. Okay, the average rate of change is just the slope. So from 0 to 2, let's see what we're talking about. Okay, let's see. So 0 is right here. So there's an x value of 0. And then 2 is over here somewhere, like off the graph. Okay, so we want the slope between those 2 points. So here's what you should do. I encourage you to make a table of values, alright, to help you with the slope. So here's my table, x, y. When they give you this interval, 0 to 2, they are giving you x values. So they're giving us an x value of 0 and then an x value of 2. To calculate the slope, we need the y values that go with these. Alright, for the 0 one, we can just look at the graph. It's 0, 1. Okay, but for an x value of 2, it's way off the graph, so we need something else. How can I find out what the y value is when I know that the x value is 2? What can I do? Well, hopefully you said something about substituting the x value back into the equation they gave us. So basically the y value is going to equal 2 times 2 squared, because that's x, plus 4 times 2 plus 1. Whatever this is, that's going to be the y value. Alright, so we can just type this in. 2 times 2 squared plus 4 times 2 plus 1 plus 4 times 2 plus 1. So that's 17. Alright, so we have the point 2, 17. So these are the 2 points. We'll use this to find the slope. Now, we know that rate of change is the slope. Alright, and when we're talking about slope, the formula for slope is going to be y2 minus y1 over x2 minus x1. So all we have to do is use the slope formula to calculate the slope right now. So here I go. Alright, so it's y's over x's. So y2 minus y1, that's 17 minus 1. x2 minus x1 would be 2 minus 0. That's going to equal 16 over 2, which equals 8. So 8 would be the rate of change.